Imagine a mysterious visitor from deep space, gliding silently past our solar system. Its name is 3I/Atlas, the third known interstellar object ever detected by astronomers. Now, comets and asteroids usually follow a predictable pattern. As they travel through space, they lose material. Dust, ice, and gas stream away from their surface, leaving a trail behind them. But what if something different was happening this time? Some researchers began to ask a strange question. Could 3I/Atlas actually be getting more massive as it travels? On the surface, that sounds impossible. Objects in space don't usually gain weight out of nowhere. Yet the way this interstellar wanderer behaved left some scientists puzzled, and that mystery gave birth to bold new ideas. So today, we're going to dive into this fascinating debate. Is 3I/Atlas really breaking the rules of space physics? Or are we misinterpreting the evidence? And what does this mystery tell us about interstellar objects in general? The answers might surprise you because the truth lies in the fine balance between science, uncertainty, and imagination. 3I/Atlas was discovered in 2019 by the Atlas Survey in Hawaii, the same sky-scanning project famous for spotting dangerous near-Earth asteroids. Almost immediately, astronomers realized it wasn't like the usual comets we see. Its orbit was hyperbolic, meaning it wasn't bound to our sun. Just like the famous Oumuamua before it, Atlas came from another star system and was only passing through. Normally, when we look at comets, we know what to expect. As they approach the sun, their icy surfaces heat up and start releasing gas. This process, called outgassing, creates a beautiful glowing coma and a long tail stretching millions of kilometers. But it also means the comet is losing mass bit by bit, gradually eroding as it makes its journey. Atlas, however, showed signs that didn't fully fit this standard picture. Its chemical makeup looked unusual, its coma glowed differently than expected, and its motion through space raised questions. Instead of accelerating in the way most comets do when gas jets push them around, Atlas appeared strangely stable. And that's where the idea of it being more massive, or even gaining mass, began to spread. Here's where things get interesting. Scientists don't measure the mass of a distant comet directly because they can't just weigh it. Instead, they infer mass from behavior. If a comet is small and lightweight, even a little gas escaping its surface can push it off course. If it's heavy, those same jets have much less effect. So, by carefully tracking its path, astronomers can estimate its size and density. In the case of 3I/Atlas, astronomers noticed it wasn't accelerating in the way a typical comet might. This led some to suggest that it must have a large, dense nucleus, far heavier than expected. From this, the story evolved. If it was unusually massive, could it also be somehow getting more massive as it traveled? But here's the catch. Being massive is not the same as gaining mass. The idea of getting bigger is more of a misunderstanding than a proven observation. Atlas may simply be large and stable, with unusual chemistry that makes its activity harder to detect. Yet because it behaved differently, speculation quickly caught fire. People began to wonder, was this comet breaking the rules of physics? Let's step back and think about what it would actually take for an object in space to gain mass. There are only a few possibilities. The most obvious is a collision. If Atlas collided with another asteroid, comet, or even a fragment of dust large enough to stick, it could, in theory, add material to its body. Another possibility is moving through a dense region of space filled with gas or dust. In that case, the comet might sweep up particles as it travels. But here's the problem. None of that seems to be happening with Atlas. No sudden trajectory changes have been recorded, no bright flashes of a collision have been seen, and no dust clouds appear to be clinging to it. Instead, the more likely explanation is that Atlas is losing material, but in a way that's harder to measure. Its chemistry is strange, dominated by gases like carbon dioxide, so its outgassing doesn't create the same kind of visible acceleration we usually see. So scientifically, the evidence points against it growing larger. It's almost certainly not gained mass. Instead, it reminds us how tricky it is to study small, faint objects billions of kilometers away. So why does the idea of 3I/Atlas getting more massive persist? The answer is simple. Mystery excites us. Whenever astronomers encounter an object that doesn't behave as expected, the human mind starts filling in the gaps. What if it's an alien probe? What if it's breaking the rules of physics? What if we're witnessing something brand new? This isn't the first time speculation has gone wild. When Oumuamua zipped past Earth in 2017, scientists noticed its strange acceleration and flat, elongated shape. Some even suggested it could be artificial. With 3I/Atlas, the talk of gaining mass adds to the same sense of wonder. Even if the evidence isn't there, the mystery sparks imagination. Speculation is not a bad thing. It often pushes science forward. By questioning the strange, astronomers are encouraged to gather more data, refine their theories, and improve their instruments. The key is balancing curiosity with evidence. Atlas may not actually be growing, but the very idea forces us to rethink what we know about interstellar objects. And sometimes, asking impossible questions is how science makes its biggest leaps. So what's the truth about 3I/Atlas? Based on the data we have, it isn't growing more massive. Instead, it seems to be a heavy, stable, interstellar object with unusual chemistry that makes it look different from what we expect. The idea of it gaining mass is more speculation than science, but that doesn't make it any less fascinating. Every time an object from another star system passes through our cosmic neighborhood, we're reminded of how little we know. Are these interstellar visitors just ordinary comets, or do they hide secrets that could rewrite our understanding of planetary systems? 3I/Atlas may not give us all the answers, but it leaves us with better questions. Now, I want to hear from you. Do you think interstellar comets, like Atlas, could be hiding properties we've never seen before? Could some of the wild theories hold even a grain of truth? Share your thoughts in the comments. And if you love exploring the mysteries of space, subscribe, because this is only the beginning of our journey into the unknown.